Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says count subarray with given XOR. The problem goes like, given an array of integers ARR and a number k, count the number of subarrays having XOR of the elements as k. Note it is guaranteed that total count will fit into 32 bits integer. So we are provided with few examples as this, and k is 6, and they say that subarrays are 4226, this one 226, and the individual 6 over here. So yeah, these are the subarrays which we can found, and overall there are 4 subarrays here, and that's why the output is 4. Same goes with second example, same goes with the third example, because here k is 0, there are 4 multiple options, and yeah, they want us to have expected time and space complexity of n. So how can we solve this? First, they want subarrays, right? So to get all the subarrays we can do run 2 loops, I and j, but again that would cost us O of n square time complexity. We don't want to do that, right? So how are we going to do this? How are we going to solve this one? So I'll quickly note first example over here, and we can understand how we can operate on this example. So I have 4 2 2 6 4, and here k is 6. Good. Now how are we going to solve this problem? To solve this problem, we need to first understand about few of the XOR properties. So one of the property of XOR is, if XOR of any number a is XORed with itself, it gives you 0, and a XORing with 0 gives you a back again. So with these two properties, if we know, we can go ahead and solve this problem. So how can we do this one? How can we know? So let's see. This, my friends, is an array. We can have certain like index, there is 1 0 1 2, but it's not much required index. So we can go with the XOR directly then. So if I'm XORing this 4, it's an individual number, right? So if it is 4, and I can assume that hey, if I don't have anything, it's 0 over here, and 0 XORing with 4 is 0 only, since we have seen like this. And 4, if I'm XORing with 2, all I'm doing is I wanted to take XOR from starting most point to the ending most point. That's the only thing. So 4 XOR with 2 is 6. Then you go ahead with 2, you get 4. 4 6 is 2, and this 2, this 4 is back 6 again. And this is nothing but XOR, or I would say cumulative XOR. Yeah. Within this, we found that hey, 6 is possible to come up with the starting index, but we are not sure of middle index. We can verify 6 is possible with starting index or starting number 4, because 1 and 2, these two items got the starting index, went ahead with the starting element 4 and filled out. So I'm pretty much sure that hey, 6 is for sure, but I don't want to repeat the process with next index, index 1, index 2, and so on. So I'll say this index 0, it's index 1, and so on. And if it is nothing, so index minus 1, just for bookkeeping. Cool. So how we can do that? So let's use this property. If a XOR a, any number XORing with itself is 0, that means if 4 is here and this 4 is here, if I'm XORing this 4 with this 4, middle elements are 0. That means from this to this, it is 0. 2 to 2. And yeah, that is correct. 2 XORing with 2 is 0. So can I use this one? Can I use this into my benefit? Obviously. Let's start. What I'll do over here is two things. I'll first of all find what current XOR it is. I'm finding current XOR and what I should look for. So I should get a target, and we are finding for K, we need K from the subarray, so our target would obviously be XORing with K, because again, if you have K, if you have current XOR, you want that X. So it is something like what X XORing with XOR would give you K. Again, it's not that typically complicated, but just bear with me. Now what I'm saying over here is I have 4. If I'm at 4, I have currently 4 and I want 6, 2 can give me a 6. Can I see 2 on my left hand side? No, I cannot. So I'm at 6 now. I'm at 6 and I want 6. So 6 XOR 6 is 0. Can I see 0 at my left hand side? Yes, I can see that. And where it is on this position. So from here to here. Yes. Next I'll come to 4 now. 4 it is. If I'm at 4, what element I need? So I need 4 XOR 2 to get my answer as 6. So can I see 2 on the left hand side? No, I cannot. So leave it. Let's come to next. So there is 2 here, and if I want 2 XOR 4, then I can get 6. Can I see 4 on left hand side? Yes, I can see 2 4s, not 1. So one is over here, this one, a little one, and one is over here, a larger one. Interesting. Next is 6. Okay, I want 0 in order to get 6, and this is what my thing would look like. There is nothing back, so I have 4 ranges, or I should say 4 subarrays, and that's the reason, my friends, this output is 4 over here. If you want to get subarrays as well, then you have 4 2, then you have only 6, and for this you have 2 to 6, and for the bigger one you have 4 2 2 2 4, 2 to 6 4, and this is what the response is. But they don't care about subarrays, they just care about count. So we are not here to store subarrays, we are just here to store count. So only count should be provided. Again, that's cool. We can get arrays as well, but they don't want array anyways. So that makes our job little bit easier again. Now what to do? Let's get into our code now. We know the arrays as well, and we know the counts as well. So cool. So what I'll do here is I'll have int count, which initially 0. I'll return the count. Oops. Mistakenly I have just submitted this. Yeah, sorry. Let's do this. Let's take a map, because we need to store what XOR is with what count. So map integer to integer, and I want to name it as map new hash map. So what this map will do? This map will give us a current XOR, and it will give us the count, how many times it occurs. So here we have 6 2 time occurring. This is a XOR value, 2 times 6 occurring. So 6 would be pointing to 2. So yeah, that's the only thing. And also we want XOR, which initially is 0. This would be cumulative XOR. And now it begins where we wanted to iterate one by one each element. but before that we have stored 0 as an initial point before jumping into the array. So let's do here as well. So map.put 0, and it's occurring one time. So yeah, 0 means there's nothing, you have took nothing, and hence you got 1 occurrence if you're taking nothing. So for int I is equal to 1, not 1, it's 0, it's less than a dot length I plus plus, and as soon as I got this, I'll do XORing a of I. Well, I got the cumulative XOR. What next? I got a cumulative XOR. I need to check whether something is on my left hand side or not. Cool. That means I need to check the target. So target would nothing be but XORing XOR with K. Cool. And I wanted to check whether the target exists or not. How can I check? I have already a hash map. Let's check with that. I'll get this target, and if I'm getting this, I'll give it this would give me a count, you remember? So count is here, XOR to count. If I found this target XOR, it will give me a count, and I'll store the count into count plus 1. But it might be possible that it doesn't have, so default it would give me 0, a 0 count. Cool. I have updated my count. Now I wanted to register this XOR. I'll register this XOR by map dot put current XOR and map dot get or default XOR 0 plus 1. So whatever value I'm having, plus 1 to that. If not, no value I'm having, 0 plus 1, that means 1. And yeah, that's how I register. I check for next, I register, check for next, and so on. Let's try to run this. This runs well, no compiler errors so found, and yeah, it is submitted for rest of all the test cases. So this was all about it. This followed a pattern known as prefix sum. The topic is, you can see, array. Prefix sums comes under arrays topic. We use map and bit magic as well. So this was a very decent problem, and yeah, for more such content, click the video on your right, and I'll see you in the next one.